Special right triangles is the topic of today's discussion. They are geometric wonder children. First of all, let's start talking about triangles. A triangle is any polygon with 3 sides and 3 angles. Not 4, not 5. You can't even have a shape with 2, so don't even try. Angles must add up to 180. This is important because if we were to measure any of the angles, such as we will be doing later, they all must add up to 180. And with special right triangles, one angle is always 90 degrees. So the other two must also add up to 90. This is just a graphical representation that all angles must add up to 180. But something happens when we make it 90 degrees, make the one 90 degrees. What happens is we get a summation of 90 degrees in the other two as well. Now you'll notice that opposite of the 90-degree angle is a side that we know as the hypotenuse. Let's start off with some definitions. The hypotenuse is always opposite the right angle. The left side is the height and the bottom is the base. This is also important when making the area of a triangle. So, what is so special about these kinds of right triangles? Well, there are 3 kinds of right triangles. There's the scalene, there's the right isosceles, and there's just the scalene. Now, you'll notice that there are 2 scalene right triangles. The scalene one on the right can be any sum of 90-degree angles in the other 2 angles. Now, the one on the left is a 30, 60, 90-degree triangle, and it is extremely special. The right isosceles triangle is just that. It has 2 45, 45-degree angles whose sides are the same as well. Now let's talk about Pythagoras. He was one really smart dude, and he studied really hard. He found this pretty pivotal theorem called the Pythagoras theorem that stated that the squares of 2 sides of any right triangle will equal the hypotenuse squared, or a squared plus b squared equals c squared. Now this is extremely important if we want to find the side of the hypotenuse, or the side of the height, or the side of the base when we know 2 other sides. Now this is what the sides look like: A, B, and C. This is a squared, b squared, followed by c squared. Now a squared plus b squared must equal c squared, and if you were to take apart these squares, they would equal c squared, as in the summation. But why is this so great? Well, there's some consistency with angles and sides. If you knew 3 and 4 were the sides, or the measurements of the sides, and x was the measure of the hypotenuse, all you would need to do is square 3, square 4, add them together, and take the square root of 25, and you would get that x equals equal to 5. Now, special right triangles, there are 2 that we will be dealing with today, and mainly only for your exams. There are 30, 60, 90 and 45, 45, 90. The ratios are the same for all lengths. This is very important to know. First, we're going to start off with 30, 60, 90. Note that when the angle is the same, the lengths of the sides have the same ratios. This is always true. You could increase them by any factor, and the ratios would remain the same. For instance, if the hypotenuse is 2, then the bottom of the triangle, the base, is always equal to 1. Similarly, the height is always equal to the square root of 3. And you can always find this out by doing the Pythagorean theorem, such as the square of the square root of 3, which is 3, plus the square of 1, which is 1, is equal to 4. Take the square root of that, and you get 2, which is the length of the hypotenuse. If you do that for the right side, you would get the same result. The right triangle, I mean. This is also true for 45, 45, 90. If you were to make the sides on the left triangle 1.5 and 1.5, all you need to do is multiply 1.5 by the root of 2, and that's the length of the hypotenuse. You'll notice this is the same for the right triangle as well. This is always true, and it is very important that you understand this. Let's just generalize this. For any triangle whose angles are 30, 60, 90, the shortest side will be half the length of the hypotenuse, and the second longest side will equal the length of the shortest side times the square root of 3. This is always true and for any lengths of the right triangle that is 30, 60, 90. The same is for 45, 45, 90. Let's look at what we've learned today. Right triangles have one fixed 90-degree angle. This is always true for any right triangle. The other two angles must equal 90 minus x or x, respectively, which basically this is just the summation of the two is equal to x. Ratios of 30, 60, 90, and 45, 45, 90 right triangles are constant. In right triangles, Pythagoras' theorem is always true. So if you forgot on the exam the ratios between 30, 60, 90 or 45, 45, 90, all you would need to do is to use the Pythagorean theorem, and you could just find your angles that way, either way. Next week, we will be taking a look at sine, cosine, tangent, and a little tool we use to remember which angles and sides we use, such as SOHCAHTOA. And to follow that up, we will use Pythagorean triples.